Hello, everyone. So just a reminder, during our quiz on Tuesday, you get to use your VSEPR shape guide. And if you miss class or miss some of these, then we need to get it all filled in because you're only going to be able to use yours. So pull this out, follow along with me. Okay, so I'm going to start by showing you the Lewis dot structures that go with each of these. Pause the video as needed, and make sure you draw these Lewis dot structures. Okay, so get these ones in. Again, pause the video if you need to. Here's our next set. And we got these ones. And then here's 5 domains and 6 domains. Great. Now, well, what is a domain? A domain is the number of bonded atoms off of the center plus any lone pairs that are on the center. So let me give you an example. If we consider hydrogen to be the center, okay, like if this is my center atom, do you see how there's one bonded atom off of it? So it has one bonded atom off of the center, and there's no lone pairs on the center. So we add those together, we get one electron domain. But if we shift this and we decide that fluorine's going to be our center atom, then we have one bonded atom off of the center, and there are 3 lone pairs on the center, so we add that together to get a total number of domains of 4. Right? So that's what an electron domain is. Now, it doesn't matter if it is double bonds or even triple bonds, it's just the number of bonded atoms. So this carbon has 2 bonded atoms off of the center, and it has no lone pairs on the center, so it's got 2 electron domains. Okay. Now, we have these 3D model kits, and we're building these structures. So our first one is when it has one domain. So I pick a central atom that has only one port or one hole in it and bond that to the other one. Okay? And we can see 3D shape-wise, it has a linear appearance. So the electron geometry is linear. Whenever there are 0 lone pairs, the electron geometry and the molecular shape are the same. So the electron geometry is linear and the molecular shape is linear. The last thing is being able to draw the 3D shape. This one's really easy because you see how it's flat and there's nothing that's like coming out towards the camera, towards you, and there's nothing going away from the camera. So imagine that I take this model, I shrink it down a little bit, and then I fit it right into my paper. And see, we have a center atom, in this case it's hydrogen, but we can just label it as A. Like, I'm going to reserve A for my center atoms. And then I'm going to say X for my outside atoms. So I'm bonded to X, the outside atom. That is my 3D shape. I'm not worried about lone pairs on the outside. If there's lone pairs on the middle, then I would include it. And I'm not worried about if it's a double or a triple bond because I'm drawing the shape right now. So let's go on to 2 domains. So I'm going to pick a central atom that has 2 ports or 2 holes. 1, 2. And I'm going to start with 2 bonded atoms, just like this carbon dioxide. And here is my model that I've made. I have a center atom with 2 bonded on the outside. And similar to our last one, we get this linear shape. So the electron geometry, again, is linear. Now, just like I told you, when there are 0 lone pairs, the molecular shape is the same as the electron geometry. So we have linear. Now let's draw this 3D shape. I'm going to take the model and I insert it into my paper, right? I imagine that I'm inserting it into my paper. I have my center, and it's bonded to an outside atom, and then I'm bonded to an outside atom. And I show that same linearity, right? Like, is that even a word? We show that same line. It's not bent. It's exactly how it looks here. Now, look at the next one with me. let's say this nitrogen is my center. If that nitrogen's my center, here's a bonded atom off of the center. It doesn't matter that it's a triple bond. I have a single bonded atom off of the center. Also on my center atom, I have a lone pair. So I have a bonded atom and a lone pair, and I would add those together to get my total amount of electron domains. So one of these bonded atoms now needs to become a lone pair. The paddles in our model kits are the lone pairs. Okay? So when I look at this, electron geometry considers all of the domains. It doesn't matter if it's a bonded atom or it's a lone pair. So with the lone pair and the bonded atom, it's still a line. So that's why it's still linear. Molecular shape ignores the lone pairs. So if I ignore this lone pair, and I look at this and I go, well, what shape is it making? Oh my goodness, this is getting kind of boring because it's still linear. Don't you worry, that's about to change in a little bit. Now, back to our 3D shape. Okay, I need to include the lone pair, but I need to keep the geometry there. It's on the outside, and it's directly opposite from the bonded atom. So here's my center. Here's my bonded atom. And then there's my lone pair exactly on the opposite side from that. Beautiful. 3 electron domains now. So I have this boron has 1, 2, 3 bonded atoms and 0 lone pairs on the center. So let's build that model. Here's a central atom with 3 ports. 1, 2, 3. I'm going to have 3 bonded atoms. Oh, now look at the shape of this. This is different than how I drew my Lewis dot structure. The Lewis dot structure is not wrong, but this better be reflected in my 3D shape. So when we have 3 bonded atoms like this, can you see the triangle? The name of this shape is trigonal planar because it's all in one plane. There's nothing sticking out, nothing coming out, and there's nothing going in. And so, like I said, the electron geometry, I'm going to turn my page for a moment. Trigonal planar. When there are 0 lone pairs, the electron geometry is the same as the molecular shape. So we have trigonal planar again. Now I'm going to draw my 3D shape. So I need to represent this. So I have A in the middle, and then I need to be so careful with these angles. So I have an atom right here, so I'm going to draw that directly above. I have an atom that's angled down here. And I have an atom that's angled right there. So if you draw your 3D shape like a T shape, you'll get it wrong because the angles are like this. Like 3-dimensionally, this is what the angles are. Okay? Now, what if we have 2 bonded atoms and a lone pair? Look at this oxygen. We have 2 bonded atoms and a lone pair. So 2 bonded atoms and a lone pair. The electron geometry, like I told you, considers all domains. It doesn't matter if it's a bonded atom or a lone pair. So see how we still get that trigonal planar all in one plane? The molecular shape has you ignore the lone pair. Okay, so let's ignore that lone pair. And then we ask ourselves, what shape is it making? And chemists looked at this and they said that molecule is bent. Quite the name, huh? Bent. Now we're going to do our 3D. Okay. And so we need to consider the lone pair, but we got to keep the shape. So I have my atom in the middle, angled down to this atom, angled to this atom. And at the top is my lone pair. So I'm going to draw that lone pair. Okay. Now, what if we have two lone pairs? The electron geometry is still trigonal planar, but if we ignore the lone pairs, so if you ignore those lone pairs, we go back to being linear. So the molecular shape would be linear. Now, we have a choice right now, because look at how I'm holding this model. So before I was holding it like this, and now I've angled it so that I'm showing this line as instead of at an angle here. Either way is fine. It doesn't matter. You could draw it like this, copy, paste, but make this a lone pair. Or we can change the angle, but then be so careful. If I do this, there's the bonded atom, but I need to show the angle of this lone pair. It's not directly above it, right? And then same on the other side. Okay. Next, 4 domains now. Okay, so I have to find a central atom that has 1, 2, 3, 4. Okay. And then we're going to start with 4 bonded atoms. This one has a funny name. Oh my goodness, we're no longer all in one plane. Man, the 3D shape's going to get interesting on this one. So, here's my model. Cool. The name is tetrahedral. So I'll turn my paper for a moment. Tetrahedral. And when we have 0 lone pairs, the electron geometry is the same as the molecular shape. So we get tetrahedral. All right, 3D shape. So, how are we going to draw this? We need to find the plane of the paper, okay? So, see this one and this one. Those are not going to fit in the plane of the paper. I'm going to remove them for just a second. Okay, and I'll even set them up here so you can see. No, maybe, so you can see them. Okay, now that I removed those two, this lies flat. I can fit this into my paper. So let me start just by drawing that. So I have my center, and angled down is an atom, and angled down is an atom. Okay, great. This is what's in the plane of the paper, but guess what? I got one right here that's not in the paper. It's coming out of the paper towards us. Okay? And the way that we represent this in a 3D shape is now we're going to use wedges. And we're going to use a solid wedge because it's coming towards us. It's like easier to see. Solid, right? So solid wedge means it's coming out of the paper. So I drew a solid wedge, and then I'm going to write, there's one more atom. Okay, great, but there's one more that goes right there. And this one's going into the paper. It's going away from us. And what we would do is we would take a dashed wedge. Okay, so instead of solid, we used a dashed wedge. And that means it's going away from us. It's going into the paper. Beautiful. Let's make one of these. One of these is going to become a lone pair. Doesn't matter which one. All right, one of these became a lone pair. Now, the electron geometry, like we've said, is still tetrahedral, but the molecular shape ignores that lone pair. So let's ignore the lone pair. And we ask ourselves, what shape does this make? Now, it's not lying flat, okay? It's raised up. So this isn't like flat against the table. All the green ones are against the table and the red one's raised up, okay? So this red one is raised up. So it makes a, can you see the triangle? Trigonal, so we get trigonal again. but the red one's raised up and it's like a little pyramid. So it's trigonal pyramidal. And then this is what's cool about the 3D shape. Whenever we have a 3D shape and it's the same amount of domains, this is still 4 domains, 3 bonded atoms, 1 lone pair. We can literally take this, copy, paste, but I'm gonna make one of the wedges a lone pair. So if I hold it like this, ooh, yeah, look, this is definitely coming out of the page towards you. So, yeah, A, angled down here, angled down here. I get my wedges. But now one of the wedges is going to be a lone pair, and the other wedge is still a bonded atom. Okay, so 2 bonded atoms, 2 lone pairs. Okay, 2 bonded atoms, 2 lone pairs. Now, our electron geometry is still tetrahedral, but we ignore the lone pairs for molecular shape. So if I ignore those lone pairs, look at what it goes back to. It goes back to being a bent molecule. And what's cool is that we get to copy paste our 3D shape. And now both of our wedges are lone pairs. There's a lone pair going out of the paper towards us and a lone pair going into the paper away from us. And then our last one is, what if it was 3 lone pairs? 1, 2, 3 lone pairs, okay? Now our molecular geometry is linear. Okay? So with this, I'm going to do the same thing again, or it's like I'm going to copy and paste this, but I only have 1 bonded atom, and I don't care which one we choose. Like this can still be our bonded, but our other one's now a lone pair. So we need to draw that. Let me show you what the model. See, that's the angle, that's the lone pair off there. And then we have another lone pair that's coming out of the paper towards us. So that's going to be my solid wedge. And then there's another lone pair that I'd put right here that would be going into the paper away from us. So that would be the dashed wedge. Okay, beautiful. Next. 5 domains. Okay, great. It's going to get exciting. So, pick a central atom that has 5. Okay, so 1, 2, 3, 4, and then look, there's a 5th one right there. 5 bonded atoms. I'm definitely going to have to scoop the camera back for this one. Alrighty, so here's our model. Now, let me first, I'm going to hold it right here. Can you see that triangle? Right here, triangle. So we get another trigonal, but then let me hold it this way. So now the triangle's in the middle. And so then above the triangle, we have one above the triangle and we have one below the triangle. Okay? So I'm going to remove the one that's below the triangle for just a moment. Look at what happens. We get this triangle on the bottom and then there's one sitting up above it. Okay? And so we get this like pyramid again. But then if we put the bottom one back and we remove the top one, then we get the same thing. We get that triangle and it becomes a pyramid again. So we have a pyramid on the top and then we have a pyramid on the bottom. So that's why it is called, I'll turn my paper paper. That's why it's called trigonal. Bipyramidal. Trigonal bipyramidal. So we get the triangle center, bi as in two, and then pyramids, two pyramids, okay, one above, one below. When there are zero lone pairs, the electron geometry and the molecular shape are the same. So this would be trigonal bipyramidal. Okay, great. Now, how do we draw this 3D shape? Okay, what we do, see, here's our triangle, but I'm actually going to turn it this way. And do you see this, like, T that it makes? Let me remove the other two that are not part of the T. See that T? And look, it lays flat. So this is going to be the plane of my paper. And I'm going to draw it just like that. So I have my one in the middle. Bonded to two atoms that are exactly opposite sides of it, and then one directly below. Okay, now we have to add the two that I removed. So we have one atom that's coming out of the paper towards you. So that's our solid wedge. And then we got one more down here that's going into the paper away from you. And so that's going to be our dashed wedge, because look at how hard that is to see that one as it's moving away from us. So a little dashed wedge to that one. Okay, great. Now, what if one of these becomes a lone pair? First, we can't choose the ones at the top or the bottom of the triangle. And here's the reason why. Do you see how it's 90 degrees away from all the other ones? But if we pick one of the triangle ones, so look at the triangle, these are 120 degrees away from each other, so they're a little more spread out. So a lone pair would rather be spread out, so it goes to one of the triangle ones. Okay, great. Now, the electron geometry is still trigonal and then bipyramidal. Pyramid on the top, pyramid on the bottom. But when we remove our lone pair, now we think, what does this look like? And it's so funny to me. Okay, so watch. See how it kind of goes back and forth? So it goes doot doot. Genuinely, they call it seesaw. Isn't that crazy? And then the cool part, we're going to take how we drew this, and I'm going to copy and paste it. So I have my like little T that's all in the plane of the paper. And then I'm going to take my two wedges, and it doesn't matter which wedge you choose, but one of them is a lone pair and one's a bonded atom. Okay. Now let's add another lone pair. And it has to go in the triangle again. So like here's our first lone pair, and so then I'm going to pick one of the other triangle pieces. Like that one right there, okay? And so now, what shape does it make when we ignore those lone pairs? Oh, it makes that T shape. And that's what we get. We call it a T shape. So I'm going to copy and paste this. This is all in the plane of my paper. We get a solid wedge, that's a lone pair, and we get a dashed wedge, that's a lone pair. Okay, now the last lone pair is the final part of the triangle, so I'm going to remove that. Final part of the triangle, and now look at what it makes. If we ignore these three lone pairs, it goes back to being linear again. So you get linear. Okay, So copy and paste, but now it's 3 lone pairs. So lone pair, and then I'm going to put a lone pair at the bottom as well. So I still have that linear right through the middle. All right, you guys are doing awesome. We're almost done. 6 domains. Okay, a lot of atoms that we got to add on here. Now, this is the crazy thing. Even though it's 6 domains, we got 6 bonded atoms, the name is octahedral, like as in 8, octa. So the electron geometry of this is octahedral. Now, this is why I believe it's called this. I could be wrong, but this is what I think. If we took this shape and we turned it into dice, if we turned it into a die, it would be an 8-sided dice. Like if we think about it, here's a triangle face right here, like that's 1, and then 2, 3, 4, and then we get the same on the bottom. So this would be an 8-sided die. And so I believe that's why they call it octahedral. Now, if we have 0 lone pairs, the electron geometry and the molecular shape are the same. And the 3D shape's actually really not that bad, even though this looks rather complicated. Look at this like plus sign that it makes in the middle there. I'm going to remove this atom that's coming out of it towards you. Okay, so I'm going to remove that one. And then there's another one on the other side going away from you. So I'm going to get rid of that one for a minute. This is what's in the plane of my paper. Okay, this is what's laying flat. So let me draw that first. Now there's 2 that I removed though. I removed one that's coming directly out of the paper towards you. So that's going to be a solid wedge. And then I have one that's going into the paper away from you. Okay? And that's going to be a dashed wedge. Alrighty, let's make one of these a lone pair. It doesn't matter which one, grab any of them. Okay. Now it's just one pyramid instead of 2, right? See that square at the bottom and then pyramidal? And so then we call it exactly that. Square, pyramidal. Okay, so the bottom is now a lone pair. We're going to copy and paste. Let me change this angle so you can see it. And now the way that I have it sitting right now, the one that's coming out of the paper towards you is still a bonded atom. So the solid wedge is still a bonded atom, and going into the paper away from you is the lone pair. Now what if the second one is a lone pair? It has to be directly opposite from it. So here's a lone pair, and then this one's going to be directly opposite. The electron geometry is still octahedral because we consider those lone pairs. But the molecular shape ignores the lone pairs. And so what we end up with is a square, and it's all in one plane. So we call it square planar. Okay, so for our 3D shape, I'm going to copy, paste what I got. Even I'll angle it so you can see it. And then there's a lone pair coming out of the paper. So that's our solid wedge is a lone pair. And there's a lone pair, so just dots. And then there's a dashed wedge going into the paper. It's a lone pair. Okay, nice. Good job, everyone. And just as a reminder, you get to use this paper on your quiz. So thank you for taking the time to get this filled out.